Hi, my name is John and welcome to another edition of Statistics Quest. This is part two of Is Tom Brady the greatest quarterback of all time? Okay, and the way we're going to do this is by the use of something we call Bayes' theorem. We mentioned that in part one. And I'll explain how I'm going to do this. Okay, first of all, some of you may know Bayes' theorem by this formula if you took a statistics class. Ignore that, basically. But what Bayes' theorem, because we're going to do it a little bit differently, there are different forms of Bayes' theorem. Basically, Bayes' theorem takes a prior belief, it takes then evidence to update a belief, okay? And the reason we're going to use Bayes' theorem is because in football, it's very hard to quantify what a player has done because of team and coaching dynamics, okay? So instead, particularly with Brady, who was not well sought out after coming out of college, we're going to use his projection, okay, which wasn't real good, with what he did, which is difficult to quantify, and we'll get into that in a second, and kind of mix that together, so to speak, with an updated projection, which I'm going to call a proxy for his performance. In fact, I'm going to do that and compare him to another great quarterback. It could be any great quarterback. It's just for a comparison of one guy to another. This other great one I'm going to call Peyton Manning, but it could be anybody. I'm just going to use Manning as an example, okay? And I'm going to basically do this in a baseball sense because baseball is much more concrete. I'm going to use a statistic called WOBA. It's weighted on base average. Don't worry about what it is exactly. You can find it online. And what I did was everybody in my database with at least 2,000 at-bats, I created two groups. I took the top 50% of at-bats, I called them stars. The bottom 50% of at-bats, I called them, potential stars. And then the bottom, potential contributors, right? It doesn't matter what name you use, okay? I said that Manning was a potential star, and Brady, Manning was #1 pick overall. Brady was a late 6th round pick. I'm calling a potential contributor. Now, what we're going to use something called the beta distribution, okay? And I'm not going to get too caught up. Don't get too caught up in these. Sometimes terms are a little bit a little bit intimidating. The beta distribution has a mean, an average of alpha over alpha plus beta. We'll get to that in a second. Those are two Greek letters. The beta distribution is much like a bell-shaped curve. Many of you are probably familiar with that, right? For example, we also call that a normal distribution. For example, IQs. Okay. For example, I just made this up. Alpha equals 2, beta equals 2. This is the distribution that we would see. Okay. It has a mean of 0.5, which we could plug in, but it's kind of wide. Okay. As alpha is 10 and beta is 10, it becomes a little narrower. And then as alpha is 100 and beta is 100, the means are always 0.5. It becomes narrower yet. Okay. What's the significance of this? Well, we want to find alphas and betas for both Manning and Brady that fit their projections, okay? And we'll see how that works. So alpha and beta are not really sample sizes, as I mentioned here, but they're akin to it. And the bigger alpha and beta is, the more narrow this gets. And the effect of that is kind of a confidence on what a player, or whatever the context is, whatever the probability is, okay? And again, it'll make a little more sense with numbers, okay? The stars. Okay, I mentioned the stars were the top 50% of at-bats. Their mean WOBA was 351, okay? And their extremes, right? If you think of a normal distribution, right, an IQ, right? What is it? 95% of all IQs are between 70 and 130, right? Almost all of them. In fact, 99.7% of all IQs are between 55 and 145. Same type of thing here. I wanted to find an alpha and beta that had a mean of 351, which is a potential star, and also had a distribution that approximated the bar chart I get when I look at the database, right? So many of you have probably done a bar chart in Excel, right? It's just the height represents the value. So I did that for stars. I did the same thing for contributors. I didn't draw the bars here, but it's the same idea. The contributors had a mean WOBA of 0.316, obviously lower, right? So, what's that really saying? I'm saying that Brady had a WOBA projection of 316, Manning had one of 351, and these are the alphas and betas that actually create that. And we'll see how that's used. Okay, so again, Manning is a projected star, right? His mean is 351 on base average. By the way, this is different than batting average, but I'm going to kind of use it like batting average. So, for example, if you go 4 for 10 in baseball, right, or softball, whatever, your batting average is 4 hits and 10 at-bats. That's a numerator and a denominator. WOBA doesn't work that way because you don't have a numerator and a denominator, but it is a decimal number, a percentage, and so you can create a numerator and a denominator. So, for example, if you go to the plate 10 times and you have a WOBA of 0.4, that is basically the same thing as 4 hits out of 10 at-bats. So this same idea. So in other words, we can tease out the number of hits from the WOBA. Okay. How can we project the WOBA of any given point of a player's career? Okay. Here is the formula: number of hits plus alpha over number of hits plus alpha plus beta. So, for example, let's just say Manning comes into and he's projected to have a 351 in baseball. Excuse me. And he has a WOBA of 0.3 after 20 at-bats. What would that be? That would be 6 hits out of 20 at-bats, wouldn't it? 6 hits, because 6 divided by 20 is 0.3. I plug in, and now his projection is 347. It dropped from the 351. So that is the updated projection. Okay? Now, we're making Manning and Brady baseball players. Okay? How many lifetime at-bats do we give them? This is actually very important. And in fact, if you want to play around with numbers later, you can do that. But so how many lifetime at-bats are we going to give them? Considering a typical star may have in the neighborhood of 10,000 at-bats. Okay? Well, if we gave them 10,000 at-bats, okay? If we gave them 10,000 at-bats, so let's just say, I'm making up an example. Let's say you have a player that's projected to be a bust. That would be an alpha of 100 and a beta of 300 and a mean of 250. That would be a very weak WOBA coming out of baseball. And you gave him 10,000 at-bats with a WOBA of 400. What's happening? You get 394. What that's really saying is, with 10,000 at-bats, that basically washes away almost completely his very poor projection, right? Because 394 is almost 0.4, okay? So in other words, in baseball, if you have that full career, say 18 years, 10,000 at-bats, you're going to basically wash away your original projection, and you should. I mentioned this in the first part because in baseball, things are more concrete. We can get a handle on what 40 home runs means and so forth. So you should be almost virtually, if not completely, evaluated on your performance. Football, as I said, what is performance? So I'm going to bring in that projection in football. But I don't want to do it with 10,000 at-bats for Brady and Manning, because that would be basically washing away the original projection. And if you have any questions, by the way, on any of this, I am glad to answer, going over this rather quick. Okay. Now, so when you think of what goes into a successful team, the quarterback is the most important, but there are so many other factors, right? I mean, there's blocking, there's receivers, there's coaching. You could even be a quarterback. You could make a bad pass and it looks like a good pass, right? You can't really do that in baseball. What am I going to do? I just picked out 2,000 at-bats instead of 10,000 at-bats for a full career for Brady and Manning, okay? Now, I want to make Brady better in the regular season than Manning. The reason is, if I don't make them better, then there's no question, right? Because if they're the same in the regular season and Manning's projection was better than Brady's to begin with, it's going to end up better. And again, this projection is our proxy for how good they were. It's a proxy, using a projection. All right, how much better? Well, I'm just thinking of a couple examples. You might remember Usain Bolt. I think it was the 220. He dominated It was a 2008, I believe. Secretariat dominated the field. I look back, though. Secretariat, I know, still has of course, it's a horse, but same idea. Secretariat and Bolt. I believe Bolt still has the world record, but both of them are less than 1% better than the next best, the second best. What's my point of this? My point is, you know, if you think of the two greatest baseball players, basketball players, whatever, it's real hard to be any more than 1% better than the next one. So I'm going to make Brady 1% better than Manning in the regular season with 2,000 at-bats. Okay? Almost there. Now, what am I going to do? I'm going to, if you look at the WOBAs, Babe Ruth actually is more than 1% better, I think. Although, actually, I think Babe Ruth's maybe 0.5. It's just out there in the stratosphere. Ted Williams might be 0.49. I'm not sure. Might be 1%. Then it actually, I think it drops a decent amount, but I'm not 100% sure. But either way, so what am I going to do? I'm going to give Brady a WOBA of 450. That's superstar, right? Not quite Babe Ruthian, but kind of close. And I'm going to give Manning 1% less, which is 449. Okay? Excuse me, 44. Okay, so if Brady's is 0.45, Manning's is 0.44 in 2,000 at-bats. So if Brady's is 0.45, that would be 900 hits over 2,000 at-bats. I plug into the formula. His projection, which is what I'm calling his performance, is 0.433. Manning's is 0.431. This is 880 hits, which is 0.44 over 2,000 at-bats. Notice Manning has different alphas and betas, as I talked about to begin with, because of the distribution. Manning's is 431. I told myself I was going to accept the numbers. What does this say? Tom Brady's the greatest quarterback of all time. All right? You can go ahead and argue it. I'm not sure I believe it, but these are the numbers I went with. And anyway, so if you have any questions, criticisms, let me know in the comments. I'll be glad to respond to them. Thanks for listening, and see you next time on Statistics West.